Hey Brian, this is the last of the series for the Taylor-Maclaurin series. This one's going to be a problem just for the Taylor series. And if you remember back from the first video, I set this up, so I'm not going to go back and solve it all over again, but I will show you what the basic piece is. And again, this is going to be the sum from n equals 0 up to positive infinity of all of the derivatives, the nth derivatives, of c times x minus c to the power of n over n factorial. And again, we can rewrite that out, and we'll say that that's p of x equals, when n equals 0, this is no derivative, which is essentially just what you have, so f of c, plus the first derivative of c times x minus c of n, sorry, that's a 1, times, again, 1 factorial, it's understood to be 1, we'll leave it there just in case, plus the second derivative of c, of f with respect to c, times x minus c squared over 2 factorial, plus the third derivative of f with respect to c, times x minus c to the third power over 3 factorial, and we'll do one more. This is f fourth derivative c times x minus c to the fourth, sorry it's kind of scratchy, plus, times x minus c to the fourth divided by 4 factorial, and then plus, and then it continues on forever. So now I want us to evaluate the function f of x equals e to the x. You'll see why here in just a second. It's kind of easy for us to work this out. So notice up here we've been working with derivatives. First derivative, second derivative, third derivative, fourth derivative, so on and so forth. So let's go ahead and write those down. And if you remember from earlier on when you were learning to do derivatives, e to the x was one of the ones that your professor probably drilled in your head. The derivative of e to the x is simply e to the x, which means that the second derivative is the derivative of this, which again is e to the x. So then I get third derivative. Again, the derivative of this, which is just simply e to the x. And we'll do one more just for good measure. The fourth derivative, what a surprise, it's also e to the x. So now, if we were to set this up, and I want us to evaluate this with respect to when x equals 3. Notice before our c up here, this was gone, and we just evaluated where essentially x equals 0. Sorry, this up here where x equals 0. Now I want us to evaluate it when x equals 3. This is what makes it now the Taylor series. Okay, so now if we were to evaluate this, p of x, which is now 3, simply equals our function where x equals 3 plus the first derivative when x equals 3 times x minus c to the first power over 1 factorial plus the second derivative with respect to c, it's 2 factorial, plus we'll do one more, third derivative for x is 3, x minus c, third power, over 3 factorial, plus, and then it continues on and on for that, like that. So now what you can also see is that this essentially works out to f of 3, if we then plug this back in, this just is simply e to the third power. So that equals e to the third power plus the first derivative where x is 3. The first derivative is just simply e to the x, so that's also then e to the third power times now x minus, and in this particular case we're going to treat this as our c. X minus 3 to the first power over 1 factorial plus second derivative with respect to, or x equals 3. Second derivative again is e to the x, so that's just simply e to the third times x minus 3 to the second power divided by 2 factorial plus third derivative, again e to the x, so again e to the third times x minus 3 to the third power over 3 factorial, and then it continues on and on and on. So now what does this leave us with? So notice that I have in all of these, if this continued on and on, they're all going to have e to the third out here to the piece. Okay, so if we want to then evaluate e to the x and see what it looks like, we can now set up a summation from n equals 0 up to positive infinity. What do we have here? We have e to the third, e to the third, e to the third, e to the third. Guess what? It's going to continue on that way. So what we can then do is we can then say this is e to the third power times, notice that we also here, with the exception of the first one, we also then have x minus 3 in all of them. And notice that the power continued to go up. It's the same power as what the n was. And then we simply divide it by, again, we can write this as 0 factorial. 0 factorial is also 1. This ends up being e to the third, this times x minus 3 to the power of n, divided by n factorial. You take the summation from that, from n equals 0 up to positive infinity, and this will very similarly match our original function, e to the x, if you take n out further and further and further and further and further. What you can also then do is I want you to graph this piece is right here. I also want you to graph this piece up here, e to the x. So I want you to graph these two items that I put stars beside. Graph those, and then I want you to look as you graph it and see what happens when x equals 3. It should give you the value of e to the third power, which is approximately 20.08. I'll kind of set this right here just for a second, just so you can kind of see all the pieces. And then there is your final solution.